Hi, I'm AMIRUL. I will start with the introduction. Vehicle suspension system design is being considered as the automobile industry switches to electric motors. The suspension systems strongly impacts the ride quality, road handling, energy efficiency, and safety. The switch from internal combustion engines to electric powertrains is changing the overall of the vehicle dynamics. With the lack of engine and have a unique weight distribution, we need to rethinking the suspension design for performance, efficiency, and comfort. So for the suspension system, we have two types, which is a conventional and active suspension. For the conventional, it operates with fixed damping characteristic determined by shock absorbers and spring, providing a consistent ride quality without a real-time adjustment to changing road condition. While for the active, it utilizes electronic controls, sensors, and actuators to continuously adjust damping setting in real time, offering superior adaptability and optimal comfort and performance by responding to varying driving conditions.
Next, I will continue with review of three journals. The title for the first journal is A Review of the Vehicle Suspension System. The suspension system's main goal is to reduce the amount of vertical acceleration that is transferred to the car, which will make a cargo or passenger more comfortable. A passive suspension system with linear springs and dampers that have constant stiffness and damping coefficient. This system has drawbacks while being dependable, easy to use, and reasonably priced. The semi-active suspension system makes use of components that may distribute energy differently, such as a variable damper. Electronic control systems are used in active suspensions to regulate suspension parts. The next journal is Controller Development for Magnetorheological Semi-Active Suspension System to Improve Vehicle Safety. This paper discusses enhancing vehicle safety through a semi-active suspension system using magnetorheological MR fluid. The development involved a non-parametric linearized data-driven NPLDD double input with proportional integral PI controller as an inner loop for MR damper modeling, and improved PI controller as an outer loop for vehicle response, and validation on a Perusahaan Automobile Nasional Proton Vehicle Characteristic and Specification. To realize this design concept, magnetic rheological MR fluid and a controller to regulate electric current are introduced, replacing the conventional use of oil or gas in passive suspension system. The last journal is an integrated vibration elimination system with mechanical electrical magnetic coupling effects for in-wheel motor-driven electric vehicles. Active suspension system and dynamic vibration absorbing structures (DVAS) are two primary strategies that have been researched by employing spring and damper components to isolate the in-wheel motor from the axle. Dynamic vibration absorbing structures (DVAS) eventually absorb vibration energy. The model takes into account the coupling effect between different parameters: wheel vibration, rotor-stator eccentricity, and road excitation. That's all from me. Thank you.
For the critical analysis of this assignment, we will choose three journals. For the first journal, review of the vehicle suspension system. Considering the focus on active suspension system, the researchers' improvement would be deeper into specific engineering challenge associated with actuator in active suspension. So for about the discussion, we should mention about the aspects such as selection of the material for the actuator, heat dissipation, and reliability under varying conditions. For the second journal, we will think about controller development for magnetorheological semi-active suspension system improve vehicle safety. In this context, of the accumulated tank that mentioned in this paper, they use metal. So we will suggest some improvement about the metal, choose two metal alloys. It's about metal alloys offer improved mechanical properties such as corrosion resistant and durability compared to traditional metal that already they use in this paper. For the third journal, an integrated vibration elimination system with mechanical electrical magnetic coupling effect for in-wheel motor driven electric vehicle. The goal to improve and to critique about this paper is to improve how this vehicle handle both when the wheels are on and off the ground, while considering the impact of uneven electromagnetic fields. This explain might prevent from them being widely used, particularly in fields for application where economy of scale is the top of mind. So that's all for my part. I will pass to the next presenter. Thank you very much.
Next, we have three different segment of EV cars, which is we have Oragood Cat, BYD Atto 3, and Tesla Model Y. Starting with the suspension, the Oragood Cat uses a MacPherson configuration in the front and a torsion beam in the back. And for the BYD Atto 3, it has a MacPherson for the front suspension and multi-link rear suspension. And for the Tesla Model Y, it equipped with a double wishbone front suspension and a multi-link for the rear suspension. Moving on the tire size, the Oragood Cat rides on an 18-inch alloy wheel with the 215/50 radial tires. And for the BYD, it used with the 17-inch alloy wheels and 215/60 radial tires. And finally, for the Tesla Model Y, it comes with the 19-inch alloy wheels and 245/45 radial tires.
I will explain about the uses of suspension and various tire size on electric vehicles. For the segment A car or Oragood Cat, they use torsion beam because it is much more cost effective and require less parts. Thus, it reduces the cost for repair for the owner. And for the next one, the typical wheel size of the segment A car is between 14 to 16. However, for Oragood Cat, they have 18 wheel size because it is more proportional to its round coupe design and also for aesthetic purpose. The next car is BYD Atto 3. For BYD Atto 3, they use a multi-link independent rear suspension which can move each wheel separately from each other. For this suspension, it offers more precise control and better handling. It also provides balance between performance and comfort and handling prowess to the driver. And for the segment C car, we have Tesla Model Y. Tesla Model Y is using double wishbone suspension system where they have two wishbone-shaped arms. This allows independent movement of the wheel. This suspension system is popular for the manufacturer to get a superior performance and ride quality. Tesla is famous for their autonomous driving, thus the suspension system is actually suitable because it enhances the steering response and adapts to road irregularities. Thank you.
I'll be explaining on the discussion and proposal. So as everyone knows, the electromagnetic system, hybrid and magnetorological suspensions have provided practical solutions for a broader range of vehicles. It offers different preferences and budgets in the modern automotive market nowadays. But particularly in the urban city driving, the magnetorological suspension system could be a well-suited choice. This is because it plays a crucial role in providing a balance between ride and comfort handling in the vehicles. Besides that, it also optimizes performances, energy efficiency and integration with other vehicles system. But particularly in the fluid accumulator tank in the MRS system, which is also known as the magnetorological suspension system, the polymeric material for seals, gaskets and accumulator tank is made up of steel. These materials are prone to corrosion and may experience wear over time. Not only that, the complex manufacturing process of these materials requires energy and time in order to completely be processed. So, our group will like to improve or suggest an idea in order to improve the efficiency of the magnetorological suspension system, which is also known as the MRSS system. So basically, our group will like to improve by enhancing the use of 3D printed materials as the material surface of the wall of the accumulator tank. As you can see, there is two figures here. One with the piston, the inner view of the accumulator tank with the piston in it, and the right figure represents the cylindrical wall of the accumulator tank, which is in the blue color, that is 3D printed aluminium metal alloy. So basically this design is basically drawn in the 3D software. So our group would like to suggest by using the aluminium metal alloy as the cylindrical wall of the accumulator tank. This is because this aluminium metal alloy plays a vital role in reduction of weight in the overall system because of its lightweight characteristic. As everyone knows, aluminium material is famously known for its lightweight. Not only that, it also has the ability to withstand corrosion, which is crucial for components that is in contact with the MR fluid. So basically, MR fluid is the fluid that controls the movement of the suspension system, in detail the piston and also the damper housing in the magnetorological suspension system. Besides that, it also provides a high strength material that is selected for the fatigue resistance, ensuring the tank always maintains its structural integrity over an extended service of life. Basically, it is to this aluminium metal alloy is basically selected in order to provide a high strength quality kind of material, so that it can used for a quite period of time. Thus, in a nutshell, this aluminium metal alloy made a good choice of selection in order to prevent wear and corrosion over time. That's all from me. Thank you.
So in conclusion, our journey to the dynamics of electrical vehicle suspension has uncovered crucial consideration for future of automotive engineering. The shift to the electrical propulsion demands a re-evaluation of the suspension systems, and our analysis has spotlight the strength and challenge of the various options, from the reliability of the passive system to the sophistication of the active suspension. Each choice comes with the trade-off. The integration of the magnetorological suspension system presents a promising avenue, especially to the weight optimization using the 3D printed aluminum alloy. As vehicles become increasingly prevalent, the quest for the perfect suspension system continues, aiming to the right balance between performance, efficiency, and affordability. So thank you very much.